Hey guys, welcome to my class Python for Beginners. This is lecture number 10. Today we are going to cover the remaining portion on the topic of lists and also iteration over lists. So let's just dig right in. And the first thing we're going to study today is list slices. So we have studied about slices and strings. This time we're going to study slices over lists. So guys, launch your Python shells. Alright, so let's say we have a list, and this is equal to, this has the characters A, B, C and D. Alright, now you want to take a list slice like a list 1, 2, 3. So this will return you all the elements from the lower index to the higher index, including the lower index and excluding the higher index. So this will return elements 1 and 2 starting from 0. So should return B and C, and that's what you get. Alright, similarly you can have a list nothing and 3, just A, B, C, 0, 1, 2. Again, you can have something like 2, nothing, C and D, second and third elements, because there are only 3 elements in this list starting from 0, 0, 1, 2 and 3. Finally, a list nothing, colon, nothing, which returns the whole of the list. Now, lists are mutable. Unlike strings, lists are mutable, which means we can change their elements. Using the bracket operator on the left hand side of an assignment, we can update one of the elements. With the slice operator, we can update several elements at once. For example, a list 1 is changed to E now. So if you print a list, let's just say a list here, this is AECD instead of ABCD, because you changed the first element starting from 0. Okay, now using the slice operator you can update multiple elements. For example, a list 1, 3 is, I say, X and Y. So if you print a list now, it is AXYD instead of AECD. Also, you can remove elements from the list by assigning the empty list to them. For example, a list 1, 3 is the empty list. So now if you print a list, this is A and T. Okay. Now we can add elements to a list by squeezing them into an empty slice at the desired location. For example, currently a list is A and D. Now you want to insert B and C. So say a list 1, 1 is B and C. So if you print a list now, this is A, B, C and D. Okay, so using slices to delete list elements can be awkward and therefore error prone. Python provides an alternative that is more readable. Now we're going to learn the command delete. Delete removes an element from the list. For example, you want to remove the first element of this list. So you say delete a list 1. So now you print a list and you have deleted the first element. First element of the list was B. Okay. So as you might expect, delete handles negative indices and causes a runtime error if the index is out of range. You can also use a slice as an index for delete. For example, you can delete a list nothing to the second or the 2 minus 1, the first element. So now if you print a list, this is just t, because the 0th and the first elements have been deleted from the list. Alright. Now let's go to another topic, which is objects and values. So let's say you have two different assignment statements, which is A equals to Amit and another one is B equals to Amit. Now we know that A and B will refer to a string with the letters Amit, but we don't know yet whether they point to the same string or not. There are two possible states. In one case, A and B refer to two different things that have the same value. In the second case, they refer to the same thing. These things have names. They are called objects. An object is something a variable can refer to. We can test whether two names have the same value using equal equals. So if you say A equals B, this is true because A has the content Amit, B also has the content Amit, so they have the same content or the same value. The objects A and B have the same value, so this is true. We can also test whether two names refer to the same object using the is operator. So now you want to check if A and B objects refer to the A and B variables refer to the same object or not. We know that these objects contain the same value, but does A and B point to the same object? That you can check using command A is B, and this is true. This tells us that both A and B refer to the same object, and that is second of the two. The second case which I described. First one was that they have the same value, they just have the same value, or they also point to the same object as well. So since strings are immutable, Python optimizes resources by making two names that refer to the same string value, refer to the same object as well. This is not true in the case of lists. For example, if you say, for example, if you say A is 1, 2, 3 and another variable B is A. Now if you say A is B, this is true. But before this, let me tell you something else as well. Again, let's say C was 1, 2, 3 and D also was the same list 1, 2, 3. Now you say is C equals to D, which is true because they have the same values. And if you say C is B, C is D, this is false. In the case of strings, this was true. In the case of lists, this is false. This means that C and D have the same value but do not refer to the same object. So we have the variable C, which is pointing to one list which has the elements 1, 2, 3. D is another variable that points to another list having the elements 1, 2 and 3. Now we come to the concept of aliasing. Since variables refer to objects, if we assign one variable to another, which I did by assigning B equals to A little earlier, both the variables refer to the same object. So I said A is the list containing the elements 1, 2, 3, B is a variable and we assign it the value A, and now we check if A is B, and this is true, which means that B also now refers to the same list which A is referring to. Because the same list has two different names now, A and B, we say that it is aliased. Changes made with one alias affect another. Now, if we say that B0 is equals to 5 and now you try to print A. A is also changed because A and B were referring to the same list. When you try to change the first element of the list that was being referred to by B, the changes also reflect when you try to print A because they were pointing to the same lists. Next concept today is of cloning lists. So if you want to modify a list and also keep a copy of the original, we need to be able to make a copy of the list itself and not just the reference. This process is sometimes called cloning to avoid the ambiguity of the word copy. The easiest way to clone a list is to use the slice operator. For example, let's say A is the list containing the elements 4, 5 and 6, and you say that B is equal to A, square brackets, nothing, colon, nothing. And now you print B. B is the same list. B is a list with the elements 4, 5, 6. If you see A is B, it is false. So B and A are pointing to different objects. Okay. And now if you try to change the elements of P, let's say you want to change the first element of P, and P0 equals to 5, and now you print B. B is 5, 5, 6. But if you try to print A, A is still 4, 5, 6. So guys, let's come to the last topic of today's class, which is lists and for loops. So let's open a file. Okay, this is our 10th class, and I don't know where the file 9 or py is, whatever. Okay, so the syntax of the for loops looks like for variable in list, and you have a body. An example of this which we saw was for I in range 10, print I. If 5, it prints 10 different values because a range gives us a list. Range n gives us a list which has the value 0 to n minus 1. Let's see another example of this. For example, we have the list of numbers 1, 2, 3, 4, 5, and now for index, this is just a variable. Index is just a variable, can have any name. So for index in range length numbers, we do numbers index is equal to numbers index whole square. Okay, now take a moment to think about range length of numbers until you understand how it works. We are interested here in both the value and its index within the list so that we can assign a new value to it. So if you press F5 now, okay, I need to print numbers as well. 1, 4, 9, 16, 25. So each number in the list, original list, has now been squared. Okay, so here we were interested in both the value and its index within the list so that we could assign a new value to it. This pattern is common enough that Python provides a nicer way to implement it. For example, you have to take the same example now, and instead of this, we're going to write something else. So now we are going to have two variables for index and value in enumerate numbers. Numbers index is numbers index whole square. Again, the same result. So enumerate generates both the index and the value associated with it during the list traversal. I'll give you another example. and hopefully it will make things more clear. So we have for index for index value in enumerate, let's enumerate a new list which has fruits banana, apple, say kiwi, and pear. Sorry. And now you try to print index and value and see what you get. Zero banana, 1 apple, 2 kiwi, 3 pear. Okay guys, in my last program, this program for index value, I actually didn't use the word value at all. So for index value in enumerate numbers, you can actually say numbers index is equal to the value whole square. And now you print numbers. Let's see how both the programs work, and you get the same list and the same enumeration of 0 banana, 1 apple, 2 kiwi, and 3 pear. So because in the original list banana was at index 0, so index is 0, value is banana. For apple, index is 1, value is apple. For kiwi, index is 2, value is kiwi. For pear, index is 3, value is pear. So guys, we end this lecture. Next time we're going to learn some important concepts about how values are passed to functions in Python, what are mutable and immutable objects, and also study about tuples and dictionaries. Thank you guys, keep up the hard work. See ya.